So this is a paper written by Anthony Andon, who is Iranian and sadly can't be with us today. Very difficult to do justice to someone else's paper. Lutfi's the master at this normally. In fact, I don't know why you didn't get this gig. But so I will do my best with it. But before I start, this is Anthony.
Dear esteemed participants, I am Anthony Andon, author of 12 specialized books, technical trainer in escalator inspection and standards development, with over 600 inspections to date. I am honored to have my paper presented today at one of the world's most prestigious, scientifically recognized lift and escalator seminars. We live in an age where human knowledge has advanced to understanding the behavior of the tiniest particle and exploring the most distant galaxies. So how could I possibly miss a seminar that has long stood as a milestone in my professional journey? Unfortunately, due to unexpected events, because of the tragic consequence of war and its aftermath, this treasured opportunity has slipped behind my reach. Perhaps the true beauty of dreams often lies in their elusive nature. Finally, I would like to express my deepest gratitude to the esteemed Mr. David Cooper.
All right, we'll move on from that. So, has anyone seen an escalator run away? Yep. Yeah, a few of us in the room. Many of you will have seen it on CCTV. Some of you will have seen my presentations. I did a similar presentation, I think, 3 years ago. It's really scary. It is very, very scary. So when Anthony's talking about parachutes, he's talking about safety gears, rather like you hear the term parachute used for safety gear in Europe. That's what he's saying. Why do escalators need parachutes? So it's known the history of parachutes dates back to the 18th and 19th centuries. Initially, parachutes were used to reduce the speed of falling balloons, aeroplanes, etc., and sometimes they were used for recreational purposes. After the invention of the lift safety brake by Elisha Otis, it was also called a parachute in lifts. As you're aware, installing a parachute is mandatory for all passenger cabins and under certain conditions for the counterweight as well. Unlike elevators, this mechanism is not mandatory in escalators. Auxiliary brakes, similar to parachutes in elevators, are only mandatory under one of three conditions. And when we talk about auxiliary brakes, I need you to think about that. Ray Orton, some of you will remember Ray Orton from London Underground days. He wrote a really good book about the public service escalator. And in here, he made a comment, it's a bit of a throwaway comment about auxiliary brakes, because some people think an auxiliary brake is another brake to assist the service brake. So if the first brake starts not to hold, the second brake will do the function. Other people think of the auxiliary brake as essentially the safety gear that will stop the step band rolling away. But if you look at different designs, not all of auxiliary brakes, I'm going off piece there from Anthony's stuff, not all designs are such that the step band won't roll away. So auxiliary brakes, similar to parachutes in elevators, are only mandatory under one of three conditions. Using a friction mechanism between the brake and the main shaft, when the operational brake is non-electromechanical, and when the escalator rise exceeds 6 meters. That's when it's mandatory to have an auxiliary brake. Interesting. I find the 6 metre rule, again, I'm going off piece, but I find the 6 metre rule quite interesting because a 5 metre escalator running away still does a lot of damage. So I questioned the standard on that. So the parachute system operates in one of these scenarios: protection against excessive speed, unintentional reversal in the direction of travel. Again, going off piste, it's very interesting to watch them. A down running machine, obviously the step band only rolls away in the down direction, and it's the function of the number of people, say the mass on the step band. And then they come to a beautiful stop and they look perfectly innocent as if nothing's wrong with them, but you've got a pile of people at the bottom. If you think about it, a down running machine, when it starts to run away, is running away from its rated speed, whereas an up running machine, it's going to get to a point where it goes to zero, then rolls back. So the acceleration curves are very different. Causes of overspeed and unintended direction reversal accidents are main chain breakage, simulation sprocket failure by broken teeth, step chain breakage, main brake failure, flange breakage, gearbox breakage. Some machines you see where you see someone's pushed the stop button on a machine and it rolls to a stop, and then it rolls away in the backwards because it can't hold the load. And that's a combination of the condition of the brake and the load that's on the machine at the same time. Very, very often in those environments, you see that in sports stadiums and places like that where it's a mass crowd getting to where they want to go. If excessive speed of 1.2 times the nominal speed or unintended reversal or direction of travel occurs, a device shall detect it immediately and stop it by cutting the motor off and releasing the main brake. So the main brake comes on. So rather like a brake on a lift in a power cut, it's expected to bring the thing to a standstill. A technical standard is typically a defined set of requirements, so why does it incorporate recommendations when addressing critical safety matters? Numerous reports indicate accidents where even auxiliary brakes have failed to function with full reliability. Incidentally, I was involved in an investigation. I don't know if anyone else knows this. This was a learning curve for me. Many years ago now, there was a runaway. And it turned out that lubrication, the gearbox had stripped and lubrication wasn't getting to the bits that were needed. And the reason for that is the service engineers that were doing the maintenance, they knew they had an oil leak and they kept topping it up, fine. But what transpired over a period of time was that synthetic oil was mixed with mineral oil. And actually that turns into treacle, which was a learning curve for me. I didn't know that. Moreover, detecting issues such as an increase in the length of the main chain and step chain requires highly specialised measurement techniques, while structural failures like flange breakage or cracks in the brake arm often go unnoticed. So, given that auxiliary brakes could be mandated for all escalators at minimal cost, there's a debate, implementing, especially retrofitting, implementing this measure would ensure a secondary safety mechanism is always available to prevent accidents and enhance passenger protection. That is Anton's, he's had a shave since we last saw him. So that was Anthony's presentation on the need for safety gears on escalators. I'm happy to take questions, and I know I've got people in the room that will help me out as well. Have we got a microphone? Rory, please, Adam.
I'm Rory Smith with Peters Research, and question: in the ASME code in North America, if you have more than 6 meters, but you have a variable frequency drive and dynamic braking resistors, the auxiliary brake is not required. I think it has the added advantage of giving you a controlled, repeatable stop, regardless of load. Is there any consideration of incorporating that into BSEN 1?
I don't know the answer to that, Rory, but to tip that on its head, what happens if you get a head shaft failure, a mechanical failure, and all the electrics in the world are out the picture?
then you're going to be in trouble.
You could be in trouble. Exactly. I think that's Anthony's point.
Any other questions?
All right, who thinks there should be a brake on an escalator that stops the step band running away in the event of a failure? There we go. Any standards makers in the room? Brilliant. Thank you very much. I did my best. It wasn't my paper, but thank you very much.
Thank you, Dave. Thank you very much.